Howdy. Good morning to yourself and to everyone out there in TV land. I guess I'll kick on the video because I do have a face for radio, I guess. So, hi, I'm Dr. Russ Handorf. I recently joined White Ops this last November after working for the FBI Cyber Division headquarters for 10 years. Before that, I was an InfoSec career individual for financial services industry sort of stuff. And I'm joined today with one of my colleagues, Mike. And Mike, there you go.
Thanks, Russ. Hey everybody, Mike Tery here. I've been with White Ops for 2 years. I'm a product manager. Previously, I've worked at Palantir as a big data engineer, and then before that, cool stuff with radios in aviation and agriculture. Thanks, Russ.
Sure. And we're happy and excited to join everyone and talk to you all about who we are and what we're doing and some of the fun things that are out there on the interwebs. And one of the reasons why I joined White Ops from the FBI was their mission to disrupt the economics of cybercrime resonated with me very hard and strong. And the approaches that we take with the products and solutions that we've developed in order to do so was inspiring to me and very, very cool. But just in the short time that I've been here, I've also seen the growth of the organization in the sense of what we stop and what we measure. Like when I first started back in November, we were processing about 1 trillion unique events a week, and now we're up to, I believe it's about 5 and growing. So it's a lot of data, and it's really neat to be able to see how all the various components are stitched together in order to go in and prevent various forms of cyber attacks that we'll be talking about today. So, yep, that's us. And the fundamental mission of the organization is to disrupt the economics of cybercrime through the technology solutions that we implement. And what I had previously done at the FBI, I've kind of had a bit of a career in combating cybercrime, and the marriage of that with White Ops was fantastic. But from the federal government's perspective, there's a lot of different agencies that have their fingers in this pot and in this mission. And then because of that, they have multiple different strategies, and they seem to go a lot of different directions. But fundamentally, also at the same time, to add to some complexity to the challenge that was faced back then in my life was everyone's kind of scattered and going a lot of different directions, but also at the same time, while we all use the same prosecutors, they interpret laws very uniquely in approximately about 11 different ways, because there's 11 different federal court districts across the U.S. So that added an additional challenge. So what would be prosecuted in the Eastern District of New York would be completely and wildly interpreted differently on the West Coast. And that while that is fine from the construct of the justice system, it makes working those sort of violations that much more difficult because I personally believe the internet has made the world flat again. So there's a lot of inconsistency. And where I personally, I'm slightly biased because I work for the FBI, but I believe one particular component of the giant mission of the federal government in this space where they got it right was in the Cyber Action Team. And what the Cyber Action Team is their rapid deployment team to anywhere in the world within about 72 hours. They bring to the table very sophisticated tools and investigative techniques in order to move the investigations forward. The individuals who are selected to be on the team are highly trained and highly skilled in this specific space. They are not normal run-of-the-mill folks. I'm getting some feedback. And then the other major component, which I also enjoyed, was the light touch. In other words, you probably would never even feel our presence there, but the impact of the presence was always very high. And that is a core construct of what I like to see, especially with the White Ops capabilities and solutions that we bring in. So one thing I definitely want to get out of the gate is hackers good, criminals bad. there's this construct of well, there's a lexicon construct associated with like hackers are bad. Hackers are not bad. Actually, I would argue that everyone in this call is a hacker in one way or another. When hackers break the law, they're now criminals, much like we don't have a different name for other types of fields. When they break the law, they're all criminals. So from our construct, we bring the hacker mentality and methodology to the table when we take a look at the data and develop the tools and techniques to study the adversaries that are out there and cause positive impacts for the internet. So a couple of ways that I've come to understand how criminals hide on the internet is first, they got to have infrastructure. And the most popular form of infrastructure that's out there is bulletproof hosting providers. And the image that you see is from the Ukrainian SBU from a search warrant that they conducted of a bulletproof hosting provider in Ukraine. It was, they have a YouTube video of the search warrant of the facility. It's got like James Bond style hiding mechanisms associated with it, like a false floor elevator and all that sort of stuff. The construct of a bulletproof hosting provider is a data center where criminals can hide their stuff that does not respond to law enforcement requests and are difficult to find in meat space. So these people projected their internet presence around the world, but we're all in one location. Another part of the big infrastructure is hijacked equipment and edge devices like routers or any forms of customer premise equipment, or your infrastructure is their infrastructure. Like a common joke is like your computer is my computer or something along those lines. That is the next most common piece of infrastructure because that's quickly scalable and does not require a lot of money to be exchanged, which leads a trail of evidence. And then the last one is leased infrastructure, where they actually do rent out services and various big cloud providers in order to add legitimacy to their presence on the internet. And that's something that we see as well. One of the ways that I work within the threat intel team for White Ops, and one of the things that we do in order to study the adversaries is a platform that we call Malware IAM. And Malware IAM is a framework for providing collection, analysis, and deception operations that we conduct against the adversaries that we are chasing, that then turn into markers and data results that feed into the defense and other components of the systems and solutions at White Ops. The fundamental functionality of it allows us to safely detonate malware in long-term environments, and not just like study it for 5 minutes. We run malware for weeks to months on end in order to see as well, like when we take an action against a botnet, we can see this node change its behavior as well. So that provides us valuable insight as to the human, the criminal on the other end, making these changes. So it helps us rapidly test and scale and collect and analyze malware samples of various forms and factors. And the impact that we've had thus far is produced. I think at this point we have like a new threat intel product that gets pushed out every week about another big botnet or another huge investigation about various forms of malware families. For anyone who wants to read about them, the link to it is at the bottom of this slide. But it's really incredible to see all these huge, big, nasty things that are infected on the internet get dismantled, and seeing the huge real-time results of that dismantlement. And another point that I would like that we take from a philosophical perspective that I also had from my law enforcement career is that criminal process isn't always the right solution. Sometimes the economics of the situations in which the people from their local economies, they were drawn to cybercrime because they fundamentally needed to put bread on the table. So if there's a keep it human sort of aspect to how we work, and if I can help someone get a legitimate job who was previously a criminal and now bring them to the other side of the table, that's now one less malware author on the internet and someone else who's joined the fight for us. So that's another construct that we have as we operate. So I'll kick it off to Mike.
Thanks, Russ. Again, Mike Tery here, product manager. So I'm going to talk about, how do we productize, the capabilities of the very smart people like Russ that we have and these hackers. We're dealing with adversaries on the other side, and we're dealing with pretty specific threat models. In particular, when Russ showed us those bulletproof servers, or our adversaries are using botnets or residential proxies, a lot of times what we're trying to do is detect and mitigate bot traffic because these adversaries are using these bots for a variety of threat models, things like account takeover. If a hacker is running a credential stuffing attack and pops a few bank accounts, that's thousands of dollars, if not more. And then there's a variety of other threat models, things like new account fraud, which then can be used to manipulate a platform. Of course, we're familiar with content manipulation. There's payment fraud, ticketing fraud, and other threat models that we're trying out there to essentially use the capabilities of our hackers and protect our clients. And so I'll talk about how we do that and how we productize that and automate it. So something that's really in the DNA of the company, and also I think a lot of folks here are familiar with, and this applies really well to cybersecurity, is John Boyd's OODA loop. John Boyd was a colonel in the Air Force, a fighter pilot, and a military strategist, and he developed this framework for dealing with adversaries. And it applies in cybersecurity. We have, we're observing the thing that's happening. We're trying to orient and figure out what's going on, and then we make a decision on that. Is it a bot or is it a human? And then finally, you actually want to mitigate or act on that traffic. So in the parlance of white ops, what our R&D team works on, the hackers, the threat intel folks, they work on these various slices of this framework so that we can protect our customers against the variety of threat models. So starting on the observation side, we have what are called signals. We're interrogating the environment where the interaction is coming from, where the request is coming from. So for example, a user is logging in on a bank login page. We are running JavaScript there, collecting signal, and trying to figure out is that traffic bot or not. So the signals then flow into markers, and again, our R&D team will say, okay, if these set of signals exist, then we have this marker that's going to identify the traffic as a bot, for example. A simple signal might be the mouse movement is moving at 90-degree angles. Well, a human can't do that, but an automated bot surely can. Another good example is, for example, if the browser is telling us that it's Firefox on Windows, but another signal tells us that it's Linux, well, those two things can exist, and that's another marker that's going to tell us, hey, this is a automated traffic, maybe malware-driven traffic, or something funny is going on. And then finally, those markers, once triggered, flow into a decision. We make a decision on that traffic. We classify it. Is it a bot? Is it non-standard? Perhaps things like a proxy, VPN, anonymous browsing, things that might be interesting about the traffic. And then finally, we get to the action step or the mitigation. Do we allow the traffic through? Do we block it? How do we deal? Sometimes we might want to deceive the adversary, let them through, make them think they're succeeding, and then drop the floor from under them. And then, of course, there's these feedback loops that are very important. We want to see how the adversary interfaces after the fact. And we also run into this issue where we don't want to end up as an oracle for the adversaries, letting them know that we're catching them. Surely with simple bots, that's okay, but with the more sophisticated stuff, you really got to be careful with how much information you're giving the adversary. A little bit more on the R&D side, kind of how the detection layer, that signal and marker layer we work. There's four primary components. We have the technical evidence approach, which is probably what differentiates us from other bot mitigation platforms out there in the market. Technical evidence means that we're interrogating the environment where the traffic is coming from. So whether it's the mobile in-app, native app that's generating the traffic, or a browser. If it's a browser, we're running JavaScript. mobile, we have an SDK. We're running mini Turing tests on those environments. We're collecting a bunch of signal, and we're getting definitive evidence that whether that traffic is legitimate or not. So that's technical evidence. We're looking for evidence that traffic might be bought. Then we have the global threat intel team, which is the team that Russ is on. So this is the proactive arm where they're looking for what kind of techniques are the adversaries using out there, what kind of tools are they using, what kind of deception browsing are they implementing, so that we can get ahead of it proactively, implement the signals and markers so that once they come to our customers' platforms, we're already ahead of them and catching those bots. Then we have machine learning, and this is commonly what a lot of bot mitigation solutions or edge service providers rely on, is this anomaly-based technique or machine learning. It's certainly part of the detection approach. It is a layer there, but alone it's not enough, which is why you need the technical evidence, the global threat intel. But of course, again, the machine learning is really good. We see an anomaly, for example, specific IP addresses hitting a server. Well, clearly that's nefarious, and we should be blocking it. And then finally, continuous adaptation. And this is where we have those feedback loops. It's not enough to catch the adversary at step one when they hit customer servers initially. It's all about how are they going to adapt and how are they going to change, and are we going to catch them at that second step? And that's where we require that proactive research, not just having one marker or one signal to catch the adversary, but having an array. So even if they get around one marker or signal, there's still about a dozen other markers that are triggering, and they don't know how we're catching them. So that's really core to our detection approach. So now, as far as the product, and I talked a little bit about this, this is the mitigation platform. We start on the lower left-hand side with the client. This is, again, where the JavaScript or SDK runs. This is where we're collecting that evidence. That signal flows to our decision engine. This is where our markers get triggered, where we're able to decide on the traffic depending on how it was configured. Perhaps a customer has whitelist. We classify the event as bot. Bot meaning we have evidence of compromise, we have evidence of automation, or we classify it as non-standard. Perhaps it's a VPN or proxy, or Russ and his team, has a gray list of IP addresses or devices that they'd have identified from a botnet that's spread out. Maybe there's a million IPs that are at risk. It could be a human, but at the same time, the same device has malware on it. And it's a higher risk profile that we should service to our customers and let them know. And then once we make that decision and classify that traffic, that event, we get to the mitigation step. And this is where our customers are integrated in a server-to-server fashion. They say, hey, White Ops, can you tell us if this login attempt is a bot or not? Should we block it? Should we allow it? And then we act on that traffic. It could be server-to-server or proxy, where we're actually in the driver's seat blocking that traffic on their behalf. And of course, there's customization there that can be done. And the responses vary. We can allow the traffic, we can block it, we can time out, keep the connection open, or in the really advanced cases, deception, which is probably the most exciting, just because you make the adversary think they're succeeding, and then the floor drops from under them, and they don't know where they failed. They've invested all these resources, and then the ROI goes down. That's ultimately how you beat these guys. I'll show you a quick demo. So I'll share my screen, just so this is a little bit more real for you guys. So on the left-hand side, I have a sample login page. Imagine an adversary is going to run a credential stuffing attack. They have 2 million usernames and passwords, and they're going to automate some sort of bot. You can see in terms of integration, here we have the JavaScript tag. It's one line of code that our customer would implement. This is how we collect the signal. On the right-hand side, I have a server log just to demonstrate what the customer sees on the back end and the request that they make to us and the response they get. So if I just run test, click login, the logs on the right-hand side flowed through. Our customer made a request to our server with this JSON blob with a bunch of business signal and some other signal that we request. And then finally, we respond with an action. Do you allow? Do you block this? Is it a bot? True or false? And then we have some taxonomy, threat profile, threat category, to really give transparency on what we've identified with this traffic. now I'll actually run a Selenium bot, which is a pretty simple bot. We should be able to catch it. Hopefully it works. Let's see. All right, there it is. So we have Selenium Firefox. I just set it to run against that site. So it just ran pretty quickly. You might have not seen it. But here's the response now. The action is block and bot is true. And then we have some threat categories in the threat profile. All right. So that concludes our bot mitigation presentation. And thanks for giving us the opportunity to talk. Does anybody have any questions that myself or Russ can answer?
Hi, let's see. Yes, we have one question here. In terms of machine learning from data, does this data come from security information and event management SIEM tool?
Most of the data comes from signal that we collect via our JavaScript payload or the mobile SDK. We also have other feeds that are coming from, for example, threat intel team might have created a gray list of botnet machines or other ones. So all those things play a role. And then we can also actually have our customers send us a feed of their data to augment our data a little bit further.
Okay, terrific. What is the best way for the participants? We have almost 400 of them. How could they contact you? What is the best way?
Good question. You can send me an email, Mike Tery at whiteops.com. Tery with one R.
Okay.
Yeah. Otherwise, visit our website and there should be a contact.
Okay.
Yeah, I would say go to whiteops.com and click on the contact us component of the website.
Terrific, terrific. I'll actually I'll send that through the chat so that everyone gets that. Thank you so much for joining us. It was very, very nice and detailed. I appreciate your time.